Welcome back to Made Up of Wires, where we're decompiling Castlevania Symphony of the Night. You can go to soten.z.dev to learn more about the Castlevania Symphony of the Night decompilation project. My scroll bars are kind of screwed up, look at that. You'll see a bunch of graphs that show the progress on the different overlays that we've been working on, and you'll find a link to GitHub and Discord. Hey Dizzy, good to have you back. We've been working on NZ1 lately. It's not on this page yet because I haven't uploaded it, and I've been really bad. I have such a backlog of stuff that I need to submit for PRs, and I just haven't gotten around to it. I really need to clear that out, but I don't think that'll happen until next week. 1 second. Often when I start streaming, I get a bunch of my tabs reloading, and that causes a bunch of YouTube videos to start playing. We'll get there though. So late in the stream, actually right when the stream ended, there's additional chat about the project in general, and unfortunately I lost that chat. I lost the username who came up and was asking those questions. So I'm probably gonna start a little early, maybe before most people are here, but I thought I'd go over what the repository looks like, because that's a good question. I like looking at GitHub projects that I'm interested in, seeing how they're laid out. I encourage other people to do the same. Reading software is as important typically as writing software, and knowing how to read is knowing how to read software and figure out how projects work is a very important part of all of that. So let's go look at the GitHub repo, and I'll go over the way that I would probably start and kind of talk about how things work along the way. So we're going to take that top link on soten.z.dev. It's the Soten decomp project. Ignore the top being cut off. Won't worry about that too much. I mentioned recently Cinemax and Dirt Princess adding sound effects IDs. Looks like they're still going and making that easier for all of us. So a good thing to do is start with the README. This should give you a big overview of the project and tell you what it's about. In this case, it's a work in progress. We have a bunch of the progress there. And then there's links to tell you how to build, how to decompile, and some of the progress stuff. So that's all good. So the next thing, if I was looking at starting this, I'd try to figure out what tools I'm going to need. And so over on the right, we see that it's primarily a C project. 91% is in C. Currently I'm rate limited on GitHub. We have some Python, C++. What C++ do we have? Oh, we actually do. I know what C++ we have. I'm surprised it's as high as 2.1% though. Let's see. We have, yeah, like I said, make. So it probably is a make project. And we have a make file here, and I might look at the make file, but the make file usually isn't terribly important. I expect that the default target for the make file is going to do what I want, but we might look at that and see what it is. So that it means I probably need make installed on my system. The other thing to do, like I said, we have some useful things here. The build guide. If a project is more complicated than just running make, it's nice to have additional steps for what to do, and we have that on this project. And this will tell you everything you need to do to get things set up. And I would say that any decompilation project is probably going to be a little more complicated than an application. We have a lot of external dependencies, other tools. We try to pin those with Git submodules, but that doesn't always work. There's a bunch of Python stuff that also is pinned and virtual environmented, but that takes some setup as well. And so this tells you what it is. And then one of the more important things on a decomp project versus just a regular software you might get from GitHub, you need the binaries that you're going to be working on, and you should be getting those from your own copies of the disks. Hopefully you still have a CD-ROM to rip that disk. If you have a hacked PSP, you should be able to get that as well. But that's the main interesting things in the root directory. There's a couple linker scripts here. I would actually be interested in looking at these. The player linker script was updated recently. I don't like that these are in the root because I think they just kind of mess things up. Things like ASM differ settings, again, those could be moved. Not terribly important. So then, what's the next thing to do? For most decomp projects, what you're going to see is a config directory, and the config directory is going to have the splat config in it, and probably symbols as well. And ours is no different. We have all our splat config for the different overlays. Source directory, and this is where all the decompiled source goes, and we pretty much have a mapping of the PlayStation disk layout. There's a few extra directories. PC is our portable build that we do to make sure that the things that we're decompiling are not dependent on the architecture, so architecture independent builds of the code. We have some PSP specific directories. And the other, on a C project, you'll see this a lot, is a top level include directory as well. And that include directory has all the headers that are shared between different overlays. So if we want to go in and look at an overlay, you could either start with config or source. Either way is probably fine. There's a couple other directories that I'll talk about just briefly. There's bin, which is some scripts. Most of these actually get pulled in from other tools, so we have some binary hash codes for downloading a bunch of these external tools that will eventually get extracted there. And tools is a bunch of custom tools that we have. We're doing all kinds of things, building, source maintenance, tools for extracting overlays and things like that. So starting at source, you might choose one of the directories. So the way that we have this broken up, like I said, it matches the PlayStation disk. Boss is bosses. DRA is the main game engine. Main is the PlayStation's entry point. So on a PlayStation disk, you have a, I think it's in the table of contents, but there's a identifier in the disk that tells the BIOS which file to load. We called that directory main. The actual name on the disk is like slus.0067, I think is the name on the US disk. Maria for the Maria subprogram, Richter for the Richter subprogram when you're playing it as either of those characters. Maria only exists on the PSP. I'm not sure how the Saturn layout works and if we're using this directory for the Saturn layout, so don't worry about that too much. We have a Saturn specific directory as well. Servant is the familiars. ST is for stages. Stages and bosses are the same except for what directory they're in, and then the weapon directory. So what's next? You might start with main. We have a main.c like most C projects would, and this is the entry point. This is where the PlayStation BIOS will start running the user code for this. And there's some things that I would like to just reviewing this after not looking at it for a while. There's some things that I'd probably want to change. So the heap initialization right now is going to a constant, and we can make a symbol for that, and that would be a little nicer. It tells you how much heap space we're gonna need. It does all the stuff for loading the game. We have some interesting things here for loading and how loading is done. These sim prefixes are for files on the CD-ROM. But basically, different files are loaded into memory, dra.bin being the main one. And when that's finally loaded, gets loaded to a specific offset, we're going to call this main game function. Does this get written in this file? It doesn't. We have a pointer to it, though. It's a function that exists in that DRA overlay. So this is a bunch of setup. Any PlayStation game is going to have something very similar to this. But that's really, the rest of the stuff in main is SDK code that gets linked in from the PlayStation SDK. And we're working on decompiling that as well. PlayStation games only import the libraries from the SDK that they use. So we don't have everything in Symphony of the Night, just these particular libraries. And there's more of them than just this. These are just the ones that are used here. So then you could go into DRA. This becomes a little more difficult. We have a bunch of these files. Some of them are named. We have nice names for them. Some of them are not named. They're just given their offsets in memory. And what these files are is effectively the main game engine. Let's look for that gmain game pointer. Actually, we'll do this. We'll look for main. Oh, that's why I'm not signed in. Oh. Box myself a little bit. And so let's look specifically at DRA. So we'll have the main game function. And that's finally when we start getting into game logic. Let's find that. Here we go. And this is just in this poorly named 42398. This is the offset in the file where this ultimately gets compiled to. And so this is how the game starts. So we're gonna do some things like setting the video mode, initialize, a lot of initialization, and ultimately, so we're loading the startup video. This is the Konami startup. Initializing sound, doing all this other stuff, initializing variables, and eventually we'll get down to the main game loop, which is here, and we can see what's going on. So we're rendering tile maps, rendering primitives, rendering entities. There's going to be eventually this will call into code which updates each of those entities, probably the render entity function. But we could go through this and kind of look at what the game logic is. Most games will have something like this. Most programs in general work like this, even if you're using, often you're using a framework which abstracts this, but this is called an event loop, or the main game loop. And basically, once a frame, you're going to execute this loop. And so there's things like timers where you can check to see if your function has been called once or twice this frame, depending on whether you've seen that particular time or not, and lots of other things like that. But most games are, I guess, games of this vintage at least, are written this way, single-threaded. Once a frame, everything gets a chance to update. Sometimes things get a chance to update multiple times if they're dependent on other calculations. And that's how it works. So then there's a lot more in DRA. Like I said, it's the main game engine. There's not necessarily how code is split between DRA and overlays is not necessarily straightforward. Dizik says inside file where all the files get loaded as well. Yeah, and so there's DRA also specifies, we call it GAPI or Game API. There's about 40 or so functions that overlays can call into using that struct and call back into functions that are in that DRA. I should mention that main sets up some interesting things. All of the shared memory in the game is set up by main. So things that are owned really by DRA, or we would consider them owned by DRA, they're actually allocated in main. I'm not sure why that is. It's a little odd, but we see a lot of globals that are, their definitions are in main instead of DRA, even though DRA kind of encapsulates those variables. So then we'll go into ST. ST0 is where the game starts. In ST, which is stages, these are stage overlays. Player code for Alucard is in DRA. Player code for Richter is in the RIC directory. But effectively all of the other enemy code, item code, things like that ends up being in the stages. And there's a bunch of shared things. And we've broken them out into separate headers that we can include. The way that we're building currently doesn't make it easy to share C files. I'm changing that a little bit with weapons. But the way, so weapons are kind of interesting. I can talk about those a little bit later, but if we have particle effects, which are in effectively every stage, we have a C file called eParticles, which will import this header, and this has all the code and data related to certain particle effects that happen. So we can go into a stage. I'll start with ST0. The way that we've laid these out, basically every stage will have a header.c file. And this is effectively the API that DRA uses for interacting with headers. What's strange is there's 3 different structs that we've seen for these headers. Maybe they're not structs at all. We use structs because that makes it easy to make sure that ordering and everything else like that is correct. But we've broken these up into overlay abbreviated, which drops a bunch of these bottom fields, and then the creatively named overlay 2, which is just it has slightly different fields. What's strange about that, you'd think that we want to keep this kind of encapsulated and abstracted away, and it's a pretty good abstraction, not different from what we do in an OO language today. We have our interface. This is how it's exposed. You can think of this like a vtable in C++. It's at a known address, always at the start of the stage overlay. And so DRA will call these based on the offsets in this struct. When this differs between overlays, DRA actually knows which version each stage has and will we'll know that if the extra fields or different struct is being used. It's a little bizarre, but DRA knows, and so it's not completely encapsulated. We don't have the ability to subclass or have derived or derivative overlays. That information ultimately just is known in the game engine itself. So we have a bunch of functions here. Update does exactly what you'd think. Once a frame, update for the stage is going to be called, and that subsequently will update all of the entities or interactable things in the stage. There's a hit detection function, and I am not sure, I haven't looked into this specifically. I'm not sure why this is stage specific as opposed to just in DRA. A bunch of these things effectively are never or rarely different, and so why it's abstracted this way, it's not exactly clear. Some initialization functions for when you go into different rooms, the list of rooms, the list of sprites, these are used to be able to load those things into the appropriate areas of memory. Color lookup tables, horizontally, an ordered list of all of the entities that are going to exist in the stage. Stuff about graphics. Sometimes there's cutscenes, sometimes there's not, and so if there is, and again, DRA knows when there is and when there isn't, there's a pointer to a cutscene type function, and then there's a bunch of additional data. So we have a couple of those. The other data that's typically in there but isn't part of the API, but just the structure of a stage is, we should have an entity, init, and this is the list of all of the entities in the game, and this is actually one of the reasons that Symphony of the Night is not the easiest game to mod. Everything that's in a stage ends up being put into this list. And so if you wanted to say, so we have Dracula, obviously, his fireballs and other things like that. If you wanted to add a skeleton enemy into ST0, you would have to add him into this list. But once you added him into this list, that would push everything else in memory down by at least 1 pointer or 4 bytes, changing the offset of everything else in the game. And so doing this with the existing randomizer tools is pretty impractical. But because we can recompile the game, we could include an additional C file that would no longer match, and we'd no longer have a matching decompilation, but we would be able to bring in potentially other entities that don't exist. So then each of these functions, most of the functions that I've decompiled on the stream are entity update functions, and they go back to a specific thing, usually that you see as part of the game. And those might have support functions and other things like that, but that's what those are. Often we break those up into specific entity functions. ST0, so we should have like a entity Dracula in this overlay, for example, but nobody has gone and done that work. And that's kind of the thing on decompilation projects, how deep you go into organization and making this readable. There is really up to the people working on it and what people find interesting. Is it fun splitting files and renaming things and having to update config and other things to support that? Sometimes you just want to do something brain dead like that, and you'll go through and figure out which one of these is Dracula. I don't know offhand. We can look for entity Dracula here and see. But it's a pretty likely scenario that we could rename this file entity Dracula, and obviously there's a lot of code related to that Dracula boss, and that actually wouldn't be too difficult, because all the code in here already is related to Dracula. All the data is related to Dracula. So it would just be renaming this file as well as renaming the the pointer in the splat config to where this goes. One thing I have been talking about a lot is how the PlayStation works, but we're also decompiling for the PSP and trying to share as much code as possible, because most of the code is the same between the PSP version and the PlayStation version. Usually there might be some exceptions. Oh, this is interesting. This is something I learned recently, and the person who was originally decompiling this probably didn't know it. We could get a blame and figure out who that is. The ordering ended up being wrong here, so we have a specific callout for PSP saying that this particular variable is in BSS versus this one here, which is showing up in data for the PlayStation. When variables are initialized to 0 values, of which false is a 0 value, MetroWorks actually ends up just putting this in BSS anyway. So my guess is that these could be the same thing. There is this additional 0910. I have a guess to that as well, but that is not used, and so it's probably padding. Oh, it is used. Never mind. I'm not sure why. Oh, it probably doesn't show up in the PSP version for the same reason, and the splits are just wrong. So there would be some work there to fix the splits. Actually, maybe it's not in the PSP version because it doesn't. We would have to go through and look. There's some funny things. So one other thing I should call out about how the stages are set up. Usually there's a stage header st0. It does things like set up macros to tell other includes in the shared code what stage, if there's certain conditional compilation that needs to be done. There is always an entity IDs enum, and then there may be some declarations here. I like to actually keep as few declarations in here as possible, because most of the time, like this variable that we just saw, most of the time that data is not shared between files, and so you're kind of leaking some additional information when you put it here. That's, there's an art to it. It's not really a science. Sometimes we do need forward declarations for functions. Most of the time we don't need forward declarations for functions. It can affect things one way or the other. I wonder why our builds are failing. I haven't looked at this recently. Anyway, so like I said, bosses are the same, so I'm not going to talk about bosses at all. They're identical in layout to stages. They effectively are stages, and they have it's good to decompile the stage first for each boss, because there's going to be a lot of code from the stage that exists in the boss overlay as well. And usually there's a lot of code for the behavior of the boss, and it's, in my opinion, more complicated than a lot of the other code in the game. So the next type that we'll come across is servants, and servants have a lot of the same things. Servants are the familiars. We have 5 different familiars. Only 3 of them show up in the US version of the game. No, is that true? No, I think we have these 5, right? Is Nose Demon and the alternate fairy, I can't remember what the alternate fairy is called. We must not have those yet. So these are the 5 in the US version. So the sword, ghost, bat, fairy, etc. They weren't given names, just IDs on the desk. Usually what we've done is the main C file there is the entry point, and these are much simpler. they basically have some state machine for dealing with that particular familiar's behavior. There's a bunch of drawing code for it and things like that, but those are laid out the same in each one. So bat.h is going to be where the header file is. Bat is the main implementation, and we'll see that the only one that's not done for US is sword. There's one function remaining in sword, and it's only a few instructions away from being completed. So if you want to challenge and haven't want to get involved in the project, that might be something to look at. And then same thing, things that are shared between all of the servants, they go in header files, a directory up. We also have some code that is shared across more than just the stage or familiar boundary. And that might get put up here as well at the top level. And then the last one is weapons, and weapons are a little more complicated. Right now, so weapons on the PlayStation all get loaded into the same overlay, and then there's some code that knows what the offsets are for each weapon in that overlay. And so when you switch weapons, it goes back to disk, knows what section of that file to read, and puts that into a specific location in memory for the left or right hand. There's left and right hand versions of that file. On the PSP, each of these is its own separate overlay, and there exists one for each, and then multiply that by 2 for each hand. And that's the one case, it's not integrated yet, but it's the one case where one C file is used to build multiple overlays. And weapons, much like servants and stages, they have their own API as well, and entity weapon attack is the primary function there. We do have some other ones as well. There's some differences for the PSP, and I'm not going to go into those right now, but that's generally how the code is laid out. We have tools then, and I mentioned we have a bunch of different tools. Some of these tools are things that we pull in from other projects, M2C, and the PlayStation Assembler. This was Sony's PlayStation Assembler, I believe, based on GNU AS. MIPS Match is a tool that I wrote for finding duplicate segments because we have a lot of shared code, so it can find that between things that we've already decompiled and things that we want to decompile. MWC Gap is a tool for running MetroWorks C compiler and making it look a little bit more like GCC. Saturn Splitter is something that works like Splat, but for Saturn. Splat is I don't know if it's exclusive for MIPS, but it was originally built for MIPS, and so Saturn uses the SH2, and there's a bunch of different things with the Saturn that don't necessarily apply. We have a bunch of custom tools like dupes, which was the initial tool for finding duplicates between different overlays, and it works at the function level, not at the segment level. Soten Assets is a tool that we use for extracting graphics and other data from files from the disk that are not distributable. So we have to be careful. Any code that we write is our original code, but things like images and things like that are not our original, and that transformation is mechanical. We might extract them to PNG or some other graphics format that we can round trip back to the game data, but we can't distribute those, and none of that is checked into this repository. I don't know what debug module is. Yeah, I don't know what that is. Soten Disk is a tool that will rebuild. It extracts BinQ ISOs. It has specific code for some of the funny CD modes that bchunk and some other tools don't necessarily support. The permuter is used for when we're very close to finding a match, but don't have a exact match. It'll tweak some of the C just a little bit to try to find some small change that will match. Sometimes it works, sometimes it doesn't. It'll put some garbage code in there as well. That sometimes is enough to kick the registers into what we need them to be. So in string, this is an interesting one. Much of the string encoding in the game is not ASCII, which kind of makes sense because the game was originally written in Japanese, and it's not shift-JIS either, but it is basically lookups into different fonts that exist both in the BIOS and elsewhere. And so I'm not sure when this was written. It's always been there since I started working on the project about 1.5 years ago, but it allows us to write ASCII strings or UTF-8 strings, it's UTF-8, and wrap them in a macro, and then it will go through and rewrite the C files with the appropriate index characters instead of that UTF-8 text, which makes it really easy because we can write things like a la carte, and it'll go through and shift that A as offset 0 or 1, etc. It'll go rewrite all of those for us. So we both have a readable version of the code for us, but then can compile it back to the offsets that we need. Splat extensions are things that are specific to the game that Splat doesn't necessarily know about, but Splat lets you put in custom extension types. Split JPT, I don't know what that is, and VabEX, I don't know what that is either. Make config is probably what I should say that most people will use, but that's the way to import new overlays. It'll look at the overlay and try to split things as best as possible and give you as many symbols as possible. Is there anything else interesting? Progress is what we use to update the progress when things are merged into master. Requirements files, so these are the things that we need to build both Python and Debian. I think that's about it. Yeah. Am I the real Count Decogila? Yes. Is that Aludocid? Dokid? That's my son, Aludokid. And what are these symbols and symbol tests? I don't know what those are offhand. Oh, symbols. Yes, I do. So we have to build symbol tables. I can show those here for things that haven't decompiled yet, but that we want to link with things that we have decompiled. So when we have code that's partially decompiled and code that hasn't been decompiled yet, we need a way to communicate addresses between those two types of files. And we do that with symbol tables. And what will happen as we go along, let me choose what's going to have, I think, BO6, that's not a good one. Oh, yeah, BO6. So we'll have quite a few. So there's 222 symbols in here. As this overlay gets decompiled more and more, there's going to be less cases where both assembly and C code need to access the same memory addresses by a particular name. And so this file eventually goes down to effectively nothing. And for the fully decompiled files, let's look at like BO4. BO4 should have very few. It has none. And that means everything is decompiled. We don't have to, the linker is going to take care of attaching all the symbols for us. There is some work being done on the Saturn version. I have not done any work on the Saturn version. At the beginning of the year, I did buy a Saturn version so that I could start working on it, because I thought that sounds like fun. And I just haven't had the chance. It's a different architecture. The way the instructions are set up are very different. I'm familiar with MIPS. I've had 20 years ago I learned MIPS, and now I'm kind of relearning all the MIPS stuff that I've since forgotten. Saturn is SH2, very odd architecture. The instruction set is just very different. So I think for a 32-bit MIPS processor, you can load 16 bytes of data at a time. So if you're loading a 32-bit value, you have to have 2 instructions to load the high and the low. With SH2, I'm pretty sure you can only load 8 bits at a time. So 32-bit values, you have 4 instructions for loading those or more. I'm not sure. It's just an instruction set that I'm not familiar with. And we don't have a lot of good tooling for it. There hasn't been a lot of decomp around that. With the PlayStation, PSP, PS2, we get to take advantage of everything that's being done on the N64, because that's also MIPS. And there just has been a lot more done because so many systems use MIPS processors. So many systems that people are interested in. With SH2, we have Saturn and 32X, and is the Dreamcast like a extension of the SH2? I know it's something else funny, but anyway. So that's a general overview. I'm not sure if the original viewer who was interested in the project layout, if they're on, but that was for them. They showed up late yesterday. Now we'll get back to our regularly scheduled program, which is looking at NZ1, which is the clock tower. We spent some time looking at Harpy and all of the things. Oh no, I did something bad yesterday, and I might have undone some of the Harpy work that we did. Let's see. I had all those nice names for Harpy. Oh, good. They're still there. I had screwed up my splat config, mapping a bunch of the shared code. I had hoped to get all of the shared code mapped in, but made a small error that ended up becoming a big issue, and I had to revert a bunch of stuff that I did last night. So we have our Harpy, and then we identified the dagger, the flame attack. I call this drumstick, but really it's the kick. The leg portion is part of the Harpy sprite. And then the feather explosion. Let's look at those and see how big each of those are, and maybe choose a medium-sized one. And we can give them names as well. So code gets extracted into the ASM directory, ASM US then it follows the disk layout, so STNZ1. We're gonna look at non-matchings and look at eHarpy. And then I like to use various Unix tools. What do I want to do? Sort R. That's what I normally do. I need an N in there. Forgetting my... So Entity Harpy by far was the largest. And that one is done for the PlayStation. Still missing some things on the PSP. I haven't gone back and done that. Let's look at B7C0. That's the next biggest, but pretty small in comparison. This is the flame attack. So I copy that. We're going to go over to decomp.me. I would like my... my header back. Start a new scratch PlayStation. Symphony of the Night preset. What is the Symphony of the Night preset? When you're decompiling you need to know what compiler was used. And how do you find out what compiler was used? Trial and error, mostly. We know, fortunately for the PlayStation, GCC was used, and we have the patches for GCC that Sony made, and GCC is GPL'd, so we have the ability to have all those patches legally, which is nice. But there's quite a few, and what's a little strange about Symphony of the Night is we know that we're using this particular minor version of GCC 2.6.3, which is age appropriate for Symphony of the Night. A little old, but still a possibility. But we're also using SciQ 3.5. SciQ was the original name for the SDK. It came from Psygnosis. It originally was an SDK for the Sega CD, believe it or not. And Sony bought Psygnosis. Did they own Psygnosis at the time? I don't know. Both Sony and Psygnosis did a lot on the Sega CD. Eventually, SciQ became the official PlayStation SDK in 1999 or 2000, somewhere around there. They finally renamed it and didn't call it SciQ anymore, and they just called it the PS1 SDK. Roaming asks, so restating that my preference is the PS1. Yes, that's correct. I'm most interested in the PS1. But typically I will bring in the PSP version of the game. And the PSP version of the game is a little easier to decompile. I shouldn't say that. The PSP MIPS assembly is easier to read. The decompiling program that we use to do the initial pass to give us some C, however, I think works better on the PlayStation version. And so when I get my initial my initial conversion from assembly to C, I like doing it on the PlayStation version. I just feel like in general it ends up structured more similarly to how it's going to end up. There's a lot of extra and superfluous instructions that end up in the PSP version of the game because the optimizer was turned off. And so you get a lot of noise in the output, and a lot of this code is very terse. So that's kind of the reason I'm a little more used to what the PS1 output is going to look like and know some of the tricks there as well. And so typically I start with the PS1 version, and then either I can't get it, or in this case I'm trying to do both at the same time. I will pull in the PSP version eventually. So yeah. Along with options, there's compiler options as well. And again, somebody has come through, Dynamo, Sozudi, Biz Murphy, before me, and gone through and figured out what each of the compiler options are. And that's not easy, not straightforward. A lot of trial and error. I think at one point Biz Murphy wrote a tool to do the permutation of all the options that we've seen. The major one is the optimization level. So which version of the compiler, which version of the linker, and the optimization level. If you get those, you're most of the way there. And once you have those for a game, you can effectively, usually every file in the game is compiled that way. It's not completely 100% true, and we have some files in this game that need slightly different compiler options, but it's pretty rare. All right. I have been meaning to write a tool, though, there are certain things that we can tell from binaries to give us a hint as to what SDK or compiler was used. And I've been meaning to to write that first, I don't know, 9 or 10 months now, and I just haven't gotten to it. Let's get this compiling, and then we'll get a match. So I'm going to put the function signature for this. We didn't provide one, so M2C came up with one for us, and it's pretty good. It chose the right argument to the function. I like calling the first variable self, so I'm going to put this in the context. And I'm going to run M2C again, and that will just give me something a little bit nicer, and something that looks more like how this is going to end up. The function declarations that are at the beginning, I get rid of those. We have one variable type that we don't know. Fortunately, animate entity I know takes a array of signed 16s. If I'd have the function signature, M2C could do that for me, but I don't. Can you tell? Just animate entity. Unsigned 8. All right. Okay, so that tells us what this type is up here. It could be an array. It could be a pointer. We don't know for certain, but we'll treat it like this for now, and then we could tell later. So we get 88.99% similar off the bat, which is nice. Most of this actually looks pretty good. The main things, so we have a go-to, we'll get rid of that eventually. The main things are these pointers to specific G entity offsets that need to be fixed. Some stuff in the middle, not worried about that right now. There's one more of those down here. And so the next thing I want to do is get rid of the go-tos. So we're going to have at least one go-to to this block 18. We have to make sure that whatever is jumping to this block 18 has the same behavior, so it destroys the entity and then exits. And that is just an optimization that GCC does. And then our differences, there's a bunch of naming things that we'll have to fix. Usually we'll fix the step first. M2C always puts it in a separate variable, but it's not there. Temp v0 we're going to call entity. And I think temp v0 underscore 2. We can treat the same way, use the same variable. Let's get rid of these others if we can. Temp s0 looks like a real variable. Call it rotation. When we don't have function signatures, M2C throws casts around everything, and it's usually good to just get rid of those. Sometimes they cause problems, sometimes they don't. The value we have here is we call it a float. This is going to be float 56, I believe. And float is the PlayStation fixed point format, which should not be confused with the Symphony of the Night fixed precision format, which is a little bit difficult. This up here is init type. We know now that, oh, I guess I'm not sure. I was gonna say, I think, maybe it is. It looks like a feather entity ID, but maybe not. We'd have to go back through and kill some harpies. Joy. And see what that is. This opacity looks like it is, oh yeah, so it's fading out as it's going. It's gonna be -8. Or -8. It's good to call out the fall through because it's not common. Oh, we have some interesting logic. This is where our difference is here. So params is going to influence how this rotation happens. I think I'm going to try this, but I think what's happening is this is going to be a plus equals for rotate. We'll see on the PSP version if that's the case. That rotation is also going to be a PlayStation fixed format. I'm screwing this all up. Yeah, not quite like that. We don't know necessarily on the PSP if, or on the PlayStation, if V0 is being used for a variable or not. Let's try this. I'm going to come back to this. Get rid of these casts. Irregular for the Switch means that there's no jump table. All right. So I think that's the only issue. So negating this subtraction, what do we know about that? Is that the same as so this shift here looks like it's happening later. So I think what's happening is that this is being done inline. 680. Grab the calculator. Is 680 a multiple of so it's 4. So this is times 180 minus 180. This is something like this, right? Yeah, but not quite right. So yeah, this is now where I would go and grab the PSP, and we can figure out what is going on. Get that back to where it was. All right. So I think we knew where these symbols were. Did we find those on the PSP? We know where entity harpy is. Now we should split this the same way on the PSP. So this is... These functions should come in the same order. This... Oh, this was flame attack. This wasn't... This wasn't feather. So if we load the assembly next to each other... Of course, now I forgot what the function was. The paths on the PSP are not quite as nice. So these functions, this is kind of fun to look at, I think, or whatever your definition of fun is. These are the same and likely will be the same implementation, but we can see one is actually the PlayStation 1 version. Oh, these aren't the same function. So these might not be correct. So let's find one with destroy entity in it. Okay, and we need destroy entity, we need create, we need move entity as well. And we need animate entity. Same ones. Let's look for create entity from entity. Same set. Oh, what else do we have that's unique in here? The 180s are kind of interesting. Still 2. What else do we have? That 56? So that needs to be loaded in 2 different instructions, so it's a little hard to search for. Entity ID 38. Still 2. Okay, let's just look at those and see if we can figure out which one of either might be the same. So this one has a set step, and ours does not. So I'm guessing it's this other one. Is that where I started, though? Correct. That's not what I wanted to do. I think this is them. Well, what is going on? Middle click is not working. Interesting. We're gonna do the same thing, but PSP, Symphony preset. And then this was actually a trick that Biz Murphy showed me when we first started doing the PSP stuff, which was just to take your PlayStation code and copy it right in. So we have one pointer issue here. So we do have some differences. Let's look at the decomp there. Okay, so this is interesting. The subtraction for the 180 is happening prior to anything else. And it does look like it is a variable. We do have a little too much on the stack. So this bar v0 and temp v0 are probably the same thing. I'm gonna try that. We are missing some sign extensions, so bar v0 is probably a sign 16. And all of that now has worked itself out. The order here is wrong. Hey, Matthias, thank you. Appreciate the good luck. Yeah, so there's a bunch of ordering here. We see that a lot on the PlayStation as well. The order of the field assignment is not strictly enforced because GCC knows that nothing else is going to be reading that at the moment, so it can do this assignment in whatever order it wants to. And even though we're changing the order, when we bring it back to the PlayStation, it'll still work out and compile to the same thing. 23. This order looks like it's wrong as well. Oh, so I didn't notice this at first, but the scale X and scale Y, when they're out of order, usually it means that it's a pass-through assignment like this. And I think these are possibly out of order. No, it's not. So we're missing an assignment up here that may be PSP specific. Oh, no, it's not. So draw flags we're setting to 7. Kind of crazy. draw flag is set to 4, and then specifically ORed with 3. What are those draw flags? It's good to know. We have a tool that will do this for us. Flag draw. Okay. So 4 is rotate, and then 3 is scale Y and scale X. Why are they doing those as a separate or equals? Only the Konami devs can tell you. The jump here is different. I'm not too worried about it. When other things get resolved, I think that'll be fine. Here, 46. This tells us that where our other variable was. And so this same var v0, oh, duh, rotation. So here's where our extra stack space came from. Should mostly be correct now. A few other things. 52. This is where the casts give you problems. And then no specific check against 0, just that not here. And that is all that's necessary for the PSP. There's going to be pointers that are different. There's some things that we could do here. It might be... Oh, no, we have that. I was going to say it might be nice to make this a reference to G entities, but it doesn't matter. We should give our GINIT a name, or sorry, EINIT a name. Other than that, that works, and we'll take it back over to the PlayStation 1, and that should work there as well. And it does. So the only thing that we are missing in this match is that a global, 2 globals are named differently, but that's not going to be an issue. And did I get the right function? F. Yeah, I did. No, that's odd. There must be another 48 in here. So our Harpy Flame attack, I should be able to put that in there. Replace the include ASM and build. Excuse the long build. Multiple definitions, why is that? I don't know. The issue is I'm including the common header. We need to include something that has all of the game-specific structs. And there we go. So we have a match with this function. Should we try to do this on the PSP? It would be nice. The globals are what is gonna mess it up, and I'd rather rename these things, knowing that this is correct, and then use all these symbols later. So there are some symbol names that we could give, which will be helpful. Let's see. Big symbols.us.stnz1. And we'll call this G init Harpy Flame. And I should have opened the PSP version to do this at the same time. When we're decompiling, we use the European version of the PlayStation because it was the first version, or the European PSP version. It was the first version of the game that had multi-language support. And I'm going to get the address of that symbol from the decomp. So if we look at what the argument to initialize entity is, it's this one. And then I think renaming this function makes sense too. We'll call the function entity Harpy Flame. Wrong one. And get the address from here. I do need to update the C file for oh, I didn't want to do the whole thing. I'm going to split this. I have both of them open. And we have one more, which is the animation. And that would make this portable then to both versions of the game. So let's look at this. I think I'm just going to call it Harpy Flame animation. And we get the address the same way. Having that side-by-side disassembled output makes it very easy to get these addresses. And then back in eHarpy, replace this variable with plain anim symbol. And now when I make, optimally, this will still be fine. And I should be able to build the PSP version of the game if I would correctly format my symbol table. And we should see this one build fine as well. This is just the symbol change, it's not the code yet. The issue that we have right now, and I don't know why this is an issue. We're not re-extracting. Oh, I used the wrong address, that's why. Let's get the right address. And we'll do it, and I think this will work. And again, this is just changing the symbols, but we'll go through and put the code in there as well. And the goal then is to eventually be able to just use a single file to compile for both the PSP and the PlayStation. Sure that this still works. So I should be able to take this and it should still work. Oh, it doesn't work. So let's see if we can tell why. So somewhere in there we lost 128 bytes. Try it one more time. Guess I accidentally got rid of something. Oops. Run the right commands. Huh. So, there's a couple reasons why this might be happening. I'm going to leave it the way that it is first. What I'd want to do is probably split this into a file that has the same set of functions in it. So have entity harpy through the harpy feather function and get these other two functions out of here. That may have something to do with it. When there are boundaries between functions, how they get packed together in the final overlay, and what padding there exists between functions changes. And so having them in the right segments or subsegments can help. I'm a little surprised that that didn't work though. We might as well do that while we're here. We go grab the PSP config. And split this into a separate file. Can't remember if we had jump tables here or not. I don't think that we did. No. So 6030, do we have any? We don't have any other RO data or anything like that we have to worry about, so that makes this a little bit easier. We do have to find the offset for entity harpy. Just 7180. So at file offset 7180, we're going to start eharpy. And we want to end it right before this last function. Which is at 8B10. I'm going to start with that file. So create a new C file. And move this include ASM there. Make sure that I'm updating the paths, which I often forget to do. And create our eharpy.c. And this eharpy.c will actually look a lot like the one for the PlayStation, and that's intentional. Let's try to build this, and hopefully I didn't make too many mistakes. Okay, that worked. And I like to make sure that I add all these. Ooh, I screwed that up. Did Git save me from being stupid? Yes, it did. Thank you, Git. So yeah, like I said, this eharpy looks now pretty much the same as the PlayStation one, with the exception being that the PlayStation one has code in it and this one doesn't. Let's first I'm going to try to put the code in this one again and see if we get a different result. Maybe we will, maybe we won't. And if this does compile fine, what I'm going to do is unify these files so that they're... That's not the one I want. That's not what I want either. That's what I want. No, still not working. So I'll have to figure out why, what's causing that error. Still, oh no, we're quite a bit more than 80 bytes. We're, or not 80 bytes, 128. So we're like 384 bytes. That's odd. Yes, the E in eharpy means entity. That's how we prefix the entity files. And thinking about it a little more, I can't share these files yet, even if I would revert this to just the include ASM or entity harpy flame. I would have to name the other ones, and that's probably not the worst idea. We just have to have the same symbol names for both versions of the game. Was I getting any? I wasn't getting any warnings. What about this? Let's build this again. This is the PlayStation version building. I want to make sure that I'm not screwing too much up. I do have to touch the nz1_psp directory. We just use that to namespace the PSP specific code. So sometimes we'll do this as well. This was before we were namespacing the PSP things. What we would do is come through and give the same symbol names to all of the functions. So on the left I'll have the PSP, and on the right I'll have PlayStation. Not NZO, but NZ1. Not splat, but symbols. There we go. Oh, did I screw up? I may have an idea. No, I'm not quite sure. I thought I might have an idea of what was going on with the PSP one. I'm not. Won't go into it right now. So each of these other entities that just has an auto-generated name, we're going to give each of those names. So we're going to have entity harpy dagger, entity harpy kick. And entity harpy feather. And now if I do the same thing on the PlayStation side, these files start to look even more similar. The only difference being the paths between them, but we can share that as well. By moving this file out of that namespace directory. First, I'm gonna get these symbols to match. Symbol is just a name for a function or a global variable, something that can be linked to something else, reference memory, basically. A name for an address. Make sure that that works like I expect. Hey, the Highlander 71, good to have you. Thank you, appreciate it. So now all of our symbol names are the same between the two. So I'm gonna go to the splat config for the PSP. And where we have eHarpy, basically I should be able to get rid of this prefix, the NZ1_PSP prefix. So now it's going to be referencing this NZ1 eHarpy file, the same one as the PlayStation. And I should be okay with that. And we'll make again. And this is how we share files between the versions of the game. Oh, and we can't because we have the NZ1 PSP prefix here, which hurts just a little bit. Right. There are ways around that as well, but we don't really use them. So had I used the same prefix up above for the assembly path, this would work fine. Should I do it? It wouldn't be the worst thing in the world to do it. It's not the convention though that we use. It's not clear to me why that's the convention. It seems like redundant information. If we look at ST, that's all the STs are, and so this would be changing the way that that's done. Bummer. Well, we would be able to share those files if that wasn't the case. Part of removing, we have a custom include ASM macro. It's a little different from what is normally done. And the reason it's custom is because it strips out the version at the top level that Splat normally puts in there. Anyway, not terribly important. So we do have one more version. I haven't been committing these as I go along. I'm leaving them in decomp.me at the moment because I want to get all the file splits completed and get that base overlay configuration checked in, and then I'll start importing code. I think it's nicer for everybody to work that way. So when I submit that initial PR for importing NZ1, it just has the deduplicated code and all the splits in the correct places, and then new code can come later. That's all I'm going to do today. We've been decompiling Castlevania Symphony of the Night, looking at the Harpy wave attack. Am I actually able to add whatever I want? Within reason, sure. What we haven't done, so if you're not familiar with some of the stuff that has been done, one of the major things, the randomizer community did integrate this, but getting the PSP Maria as a playable character on the PlayStation 1 version of the game, that was probably the biggest change. There have been other things that I've done on the stream, small modding things to find what each of these things are, the way that we've been doing that, not by changing the code in the game, but by changing the memory and the disassembler that we find, removing each of the Harpy things along the way. So yeah, you are able to do quite a bit more once you do have the code. It's still not a simple game to mod, but it's much easier when you have the code than when you don't. Anyway, that's all I got. Go to soten.z.dev, learn more about the project. I'm a contributor. It's not my project. I just love the game and have fun decompiling, have fun chatting with you all, learning new things, hopefully educating people along the way. And I'll be back tomorrow for more. We won't work on Harpy anymore. Maybe we'll move on to something else. That's all I got. Adios. Bye.